Thank you for coming, everybody. Some of you have probably already heard of Linus Torvalds. Those of you who haven't, you're the people with Macintoshes on your laps. He's a guy who delights in being cruel to people. His latest cruel act is to create a revision control system which is expressly designed to make you feel less intelligent than you thought you were. Thank you for coming down today, Linus. I've been getting emails for the past few days from people saying, "Where's Linus? Why hasn't he merged my tree? Doesn't he love me anymore?" And he walked into my office this afternoon. What are you doing here? But thank you for taking the time off. So Linus is here today to explain to us why on earth he would write a software tool which only he is smart enough to know how to use. Thanks, Linus.
Okay. So I have a few words of warning, which is I don't actually do speaking very much, partly because I don't like speaking, partly because over the last few years, everybody actually wants me to talk about nebulous visions for the next century about Linux. And I'm a tech geek, so I actually prefer talking about technology. So that's why I'm not talking about the kernel, because it's just too big to cram into a 1-hour talk, although apparently Andrew did that 2 days ago. And I'm instead talking about Git, which is the source control management system that we use for the kernel. And I'm really, really, really bad at doing slides, which means that if we actually end up following these slides, you will be bored out of your mind. And the talk will probably not be very good anyway. So I'm the kind of speaker who really enjoys getting questions. And if that means that we kind of veer off on a tangent, you'll be happier, I'll be happier, the talk will probably be more interesting anyway. I don't know how you do things here at the Google Talks, but I'm just saying, don't feel shy as far as I'm concerned. If your manager will shoot you, that's your problem. So next slide, okay. So I want to give a few credits before I start. I'll credit CVS in a very, very negative way, because in many ways, when I designed Git, it's the what would Jesus do, except it's what would CVS never, ever do kind of approach to source control management. I've never actually used CVS for the kernel. For the first 10 years of kernel maintenance, we literally used tarballs and patches, which is a much superior source control management system than CVS is. But I did end up using CVS for 7 years at a commercial company, and I hate it with a passion. When I say I hate CVS with a passion, I have to also say that if there are any SVN users in Subversion, users in the audience, you might want to leave. Because my hatred of CVS has meant that I see Subversion as being the most pointless project ever started. Because the slogan for Subversion for a while was CVS done right, or something like that. And if you start with that kind of slogan, there's nowhere you can go. It's like there is no way to do CVS right. So that's the negative kind of credit. The positive credit is BitKeeper. And I realized that a lot of people thought there was a lot of strife over BitKeeper and that the parting was very painful in many ways. As far as I'm concerned, the parting was amicable, even though it looked very non-amicable to outsiders. And BitKeeper was not only the first source control system that I ever felt was worth using at all, it was also the source control system that taught me why there's a point to them and how you actually can do things. So Git, in many ways, even though from a technical angle it is very, very different from BitKeeper, which was another design goal because I wanted to make it clear that it wasn't a BitKeeper clone, a lot of the flows we use with Git come directly from the flows we learned from BitKeeper. And I don't think you use BitKeeper here inside Google. As far as I know, BitKeeper is the only commercial source control management system that actually does distribution. And if you need a commercial one, that's the one you should use for that reason. I'd also like to point out that I've been doing Git now for slightly over 2 years. But while I started it and I made all the initial coding and design, it's actually been maintained by a much more pleasant person, Junio Hamano, for the last 1.5 years. And he's really the person who actually made it more approachable for mere mortals. Early versions of Git did require a certain amount of brain power to really wrap your mind around. It's gotten much, much easier since. There's obviously the way I always do everything is I try to get everybody else to do as much as possible so that I can sit back and sip my pina colada. So there's been a lot of other people involved too, right? That's the credits. With those out of the way, okay, so this slide is now 1 day old, and I didn't actually do the slides last night because last night I was out carousing and eating sushi. But the slides will talk about implementation of a reliable high-performance distributed content management thing. And the key word here is actually the distributed part. I will start off trying to explain why distribution is so important. If we never get past that point, I will actually be happy. If we never get to actually what Git implementation internally is, it's fine. I am not also trying to teach you how to use Git. There is this thing called google.com. What you do is, it has, you may have seen it. It has this thing you can type things into. You type Git, and then you press the I'm feeling lucky button, and you will actually get the home page. The home page has tutorials. It has a user manual. They're all in HTML. If you actually want to learn to use Git, that's where you should start, not at this talk. But as mentioned, if we actually start veering off topic into other tangents because of questions, it's all good. I already gave you kind of a heads-up warning on this. I use the term SCM, which I consider to mean source code management, that is revision control. Some other people think SCM means software configuration management and see it as a much bigger feature, including release management and stuff like that. That's not what I'm talking about, although Git is clearly relevant in that setting too. CVS, we already went there. You can disagree with me as much as you want, but during this talk, by definition, anybody who disagrees is stupid and ugly. So keep that in mind. When I'm done speaking, you can go on with your lives. Right now, yes, I have strong opinions, and CVS users, if you actually like using CVS, you shouldn't be here. You should be in some mental institution somewhere else. Okay. So before I actually go and talk about the whole distribution thing, which I think is the most important part, I'll talk a bit about the background because it invariably comes up because people, if they have heard about Git, a lot of the things they've heard about is the background for doing Git in the first place. One piece of background information is I really am not a SCM person. I have never been very interested in revision control. I thought it was evil until I met BitKeeper. I actually credit that to some degree for why Git is so much better than everything else. It's because my brain did not rot from years and years of thinking CVS did something sane. I needed a replacement for BitKeeper. The reason for that was BitKeeper is a commercial product, but Bitmover and Larry McVoy allowed it to be used freely for open source projects, as some of you may know. The only restriction was you were not supposed to reverse engineer it, and you weren't supposed to try to create a competing product. And I was happy with that, because quite frankly, as far as I'm concerned, I do open source because I think it's the only right way to do software, but at the same time, I'll use the best tool for the job, and quite frankly, BitKeeper was it. However, not everybody agreed with me. They are ugly and stupid, but they caused problems, and it resulted in the fact that Larry and I had several telephone conversations which ended up saying, oh, we'll all be much easier, much happier if we just part ways and don't make this any worse. So we did. And I made the Linux 2.6.12 RC2 release about 2 years ago and said, I'm not going to touch Linux until I have a replacement for Linux, for BitKeeper, for doing source code maintenance. And one of the replacement options was going back to tarballs and patches, but nobody really liked that anymore. So I actually looked at a lot of alternatives. Most of them I could discard without even trying them out. If you're not distributed, you're not worth using. It's that simple. If you perform badly, you're not worth using. It is that simple. And if you cannot guarantee that the stuff I put into an SCM comes out exactly the same, you're not worth using. Quite frankly, that pretty much took care of everything out there. There's a lot of SCM systems that do not guarantee that what you get out of it again is the same thing you put in. If you have memory corruption, if you have disk corruption, you may never know. The only way you'll know is you notice that there's corruption in the files when you check them out. And the source control management system does not protect you at all. And this is not even uncommon. It is very common. The performance issue, one of the things I kind of liked was a system called Monotone, which actually I think there was a talk at Google about them some time ago. I'm not sure. It had a lot of interesting ideas, but performance was so horrendously bad that I tried it for a day and realized that I cannot use it. The end result was I decided I can write something better than anything out there in 2 weeks. And I was right. So now we get to distribution. And this is the worst slide of them all. And I'm not very proud of it. And the problem is distribution is really important. But when I tried to make slides about it, I could not do it. And part of it is my obvious artistic talents, which are on display for all of you. But part of it is that it's really hard to explain. And so before I even start, I'd like to know how many people are used to the notion of a truly distributed source control management system? Well, are most of you kernel developers? No. Okay. So there were maybe 10 hands coming up. Being distributed very much means that you do not have one central location that keeps track of your data. No single place is more important than any other single place. So for example, this is why I would never touch Subversion with a 10-foot pole. There is a master Subversion repository, and it's where everybody has to write. And the centralized model just doesn't work when you want to be, let's look at a few of the cases. I say it's so much more than just offline work. But the offline work part is actually maybe the most obvious thing, which is that you can take a truly distributed source control management system, you can take it on a plane, and even if they don't offer Wi-Fi and satellite hookups, you just continue working, you can look at all your logs, you can commit, you can do everything you would do even if you were connected to a nice gigabit Ethernet directly to the backbone. And that is really important. It is doubly important when you have hundreds or thousands of people working on the same project, and they may not be literally disconnected, but in practice they aren't really well connected either. So part of distribution is this offline work theme. Even if it's not completely offline, it is important to be able to do everything you want to do from any location without having to be able to access a server. What that basic fact actually results in is that you effectively have a lot more branching, because everybody who has a complete repository and can do commits on his own will effectively have his own branch, even if you don't realize it. Even if you think of your project as just having a single branch, every single time you disconnect your laptop and start working with it, you are on your own branch. And this is really, really important. And it is very different from anybody who's used CVS, where branching is considered something that only true gurus do. How many of you have ever used CVS? Okay, everybody. How many of you have really done a branch and ever merged it in CVS? Good job. I mean, it wasn't everybody, but it was actually more than I expected. How many of you enjoyed the experience? Ooh, okay. So there were a couple. But it is considered hard. In CVS, when you merge a branch, I've done it as little as possible, but I've had to do it. What you do is you plan ahead for a week, and then you basically set aside one day for doing it. Am I wrong? I'm not seeing a lot of people saying, no, it was easy. I liked it. It's horrible. If you're distributed, you have to realize that every single person has his own branch. It's not horrible. It's not something you even have to set up. It just is. In fact, in Git, we like branches so much that a lot of people just have 5 or 10 or 15 of them. Just because once you realize that you have to have a special branch anyway, you might as well have many, and one of the branches you do some experimental work on, and one of the branches you do maintenance on. And so branching is much more inherent when you do distribution. One of the other things that to me is very important is that by being distributed, you also automatically get to be slightly more trustworthy. I have a theory of backups, which is I don't do them. I put stuff up on one site and everybody else mirrors it. And if I crash my own machine, I don't really care because I can just download my own work right back. And it works beautifully well, and I don't have to have an MIS department. I heartily suggest everybody else do the same. But this only really works in a distributed environment. If you use CVS, you can't do this. If you use, what do you use here? Perforce? Perforce. I'm sorry. I'm sure it's better than CVS. So that's part of it. One of the really nice things, which is also, maybe you don't have this issue inside a company, but we certainly have it in every single open source community I've ever seen that uses CVS or Subversion or something like that, is you have this notion of commit access. Because you have a central repository, it means that everybody who's working on that project needs to write to the central repository. Which means that since you don't want everybody to write to the central repository, because most people are morons, you create this class of people who are ostensibly not morons. And most of the time, what happens is you make that class too small, because it's really hard to know if a person is smart or not. And even when you make it too small, you will have problems. So this whole commit access issue, which some companies are able to ignore by just giving everybody commit access, is a huge psychological barrier and causes endless hours of politics in most open source projects. If you have a distributed model, it goes away. Everybody has commit access. You can do whatever you want to your project. You just get your own branch. You do great work or you do stupid work. Nobody cares. It's your copy. It's your branch. And later on, if it turns out you did a good job, you can tell people, hey, here's my branch, and by the way, it performs 10 times faster than anybody else's branch, so how about pulling from me? And people do. And that's actually how it works, and we never have any politics. That's not quite true, but we have other politics. We don't have to worry about the commit access thing. And I think this is a huge issue, and that alone should mean that every single open source system should never use anything but a distributed model. You get rid of a lot of issues. One of the things that commercial companies, distributed models actually help also with the release process. You can have a verification team that has its own tree. And they pull from people and they verify it. And when they verified it, they can push it to the release team and say, hey, we have now verified our version. And the development people, they can go on playing with their head. Instead of having to create tagged branches, whatever you do, to try to keep off each other's toes, again, you keep off each other's toes by just every single group can have its own tree and track its work and what they want done. So distributed is really, really central to any SCM you should ever use. So get rid of perforce now. And it's sad, but it is so, so true. And that was my only real slide about distribution. And I'd love to get questions, because we're now moving into other areas that, oh.
So how would you do it? How would you, if you had this monstrously awesomely big code base and you wanted to use this without stopping business for 6 months, how would you do it?
I stayed by the mic because I couldn't quite make out your question. Okay, he went away. How would you do this? So an example of actual distribution is you have a group of 5 people working on one small particular feature. And that means that for a while, that feature will be very, very broken, right? Because nobody actually creates perfect code the first time around, except me, but there's only one of me, right? So what happens is they need to have their own tree that they can work in without affecting other people. You can do this many different ways. In CVS, one of the most common ways, because branches are so painful, is that you don't actually commit. You never commit until it passes every single test. And then you have, for example, at your company, you have a very strict committing rule saying you will never, ever commit until it's passed the whole test suite. And by the way, the fact that the test suite takes 2 hours to run, tough. You cannot afford to commit. And this is something that happens at every single company. I bet it happens even here at Google. You probably have a strict test suite, and you're not supposed to commit unless it passes. And then in practice, people make one-liner changes and ignore the test suite because they know the one-liner changes can't possibly break, right? This happens, right? This is a horrible, horrible model. It just means that you make huge commits because you commit something after you've worked on it for 2 weeks. And you have 3 people working in the same sandbox because before they commit, they can't see the changes that the other people made. This is common. It happens everywhere. It's scary. The other alternative is to use branches even in a centralized environment. But branches ends up being pretty expensive to do, so you can't do them for experimental features. Even if, you don't know beforehand if it's something that's going to take 1 day or 2 weeks. But most of the time, most programmers say, hey, I can do this in 48 hours, right? And it turns out, yeah, no, you couldn't. But because you feel you can do it in 48 hours, creating a branch, even in systems that are better at creating branches than CVS, is a big pain. So you don't do it because you think you can get it resolved, and you're back to case number 1. But if you decide to create a branch, you will affect everybody else's repository because in a centralized environment, branches are global. So you're kind of screwing with everybody else, but at least you're not screwing with their main head branch. You are adding stuff to their repositories, but hopefully in a way that they won't notice. but it just make everybody's repositories bigger. So either way, you can't win. In contrast, in a distributed environment, what you do is you have 5 people. They pull the current head, which is hopefully good and tested, and they start working on it, and they start committing on it. And you don't need to wait for 2 weeks until your commits are stable, because your commits are always local. And what happens is, within that group of 5 people, you can pull from each other. That's what distributed means. There's no central location. It means everybody's the same, so you can merge between yourself. So not only can you commit every single line if you want to, without having to run the 2-hour test suite, but you can then communicate by pulling and merging each other's work, and one person finds a bug and commits it and tells the other 4 people, hey, my repository has a fix for this. And then when that group is done 2 weeks later, they can tell their manager, hey, we've done this. Can you ask the main group to pull, and they'll get this new feature. And by the way, we've tested it over 2 weeks, and it works, and it performs this much better because we have actually been able to time it before we even ask anybody else to look at it. And that's a hugely better model for doing development. And this is the model that the kernel uses. It turns out in many places we don't need all that power, even in the kernel. But so people usually don't pull within one group. But it does happen. For example, the networking people sometimes affect the NFS people, and the fact that they can synchronize actually helps. So this is a real practical advantage. Okay, somebody else has a question.
So it feels like the politics has just been moved to like an indirect political question. If everyone's got access and they're all playing with their branches and they have their sandbox and they're having fun, and, at the end of the day, there has to be merging and resolving, right, unless you have 80 billion flavors of every Linux kernel.
Absolutely. So in practice, you will never see 1,000. I mean, there will be 1,000 or maybe 20,000 different branches, but in practice, you won't ever see them because you won't care. You will see like a few main branches. Maybe you'll see only one. In the case of the kernel, a lot of people, they only really look at my branch. So even though there are lots of branches, you can ignore them. What happens is the way merging is done is the way real security is done, by a network of trust. If you have ever done any security work and it did not involve the concept of network of trust, it wasn't security work, it was masturbation. I don't know what you were doing, but trust me, it's the only way you can do security, it's the only way you can do development. The way I work, I don't trust everybody. In fact, I'm a very cynical and untrusting person. I think most of you are completely incompetent, right? The whole point of being distributed is I don't have to trust you. I don't have to give you commit access. But I know that among the multitude of average people, there are some people that just stand out, that I trust because I've been working with them. I only need to trust 5, 10, 15 people. If I have a network of trust that covers those 5, 10, 15 people that are outstanding, and I know they're outstanding, I can pull from them. I don't have to spend a lot of brain power on the question. When Andrew sends me patches, he doesn't actually use Git. It's some kind of defect. But other than that, he's a very solid person. When he asks me to pull, he does it by sending me 1,000,000 patches. Instead, I just do it. Sometimes I disagree with some of these patches, but at some point, trust means never having to say you're sorry. I don't know. It basically means you have to accept other people's decisions. And the nice thing about trust is it does network. That's where the network of trust comes in. I only need to trust a few people that much. They have other people, they have determined, hey, that guy is actually smarter than I am. That's actually a really good measure of who you should pull from. If you have determined that somebody else is smarter than you, go for it. You can't lose, right? Even if it turns out you pulled crap and somebody else starts complaining, you know who you pulled from, and you can just point to the other person and say, hey, I just pulled. Go to him. He knows what he's doing. So that's how I work. That's how probably most of my lieutenants work. I pull the networking changes from one person. He gets them from many other people that he's worked with over time. So this is how it all comes together. It doesn't have to come together to one point. In the kernel, it comes together to one point largely, I think, for historical reasons. And I've always tried to kind of encourage people to have more trees. So we do have vendor trees. We do have MM trees. We have multiple one points, and it happens to be that my one point is getting maybe more attention than it always should. But even if it doesn't come down to one point, it means that you can take these thousands of branches and ignore 99.9% of them. And you know that, hey, there are 5 branches that are really interesting to follow because I'm interested in those sub-areas. And it all works very naturally. One of the nice things about this whole network of trust is it's not just easy to do technically. It's actually how every single person in this room is very fundamentally wired to work. It is how we think. We don't know 100 people. We have 5, 7, 10 close personal friends. Well, we're geeks, so we have 2. But I mean, that's basically how humans work, is that we have these people that we really trust. It's family, it's close friends. And it really fits. You don't even have to have a mental model. It fits how we are wired up. So there's huge advantages to this whole model of network of trust.
Do you know any companies that are using distributed systems internally? It seems like there might be a risk of kind of balkanizing the code base as people not being in the same sandbox don't contribute back.
So quite frankly, there aren't that many distributed systems. There is BitKeeper. It is clearly being used at commercial companies. We might have somebody in the audience who actually knows, but what? So HP is using things like BitKeeper for the printer project. I'm sure they have a lot more companies. In the open source world, there are 2 distributed systems that are worth looking at right now. One of them is obviously Git, and you really should pick that one. But the other one is Mercurial, which actually has pretty much the same design. There are huge differences in implementation, and there's some differences in details, but it boils down to a very similar model. Git just does it better. Everything else, it's either centralized or it is too unstable or too slow to use for anything big.
Right, but is there an advantage for a company to have everybody playing in the same sandbox?
I think a lot of companies think there is an advantage to that. I know that inside companies, I don't think a lot of companies use Git knowingly, in the sense that it is a company decision. I know several companies who use Git internally, not knowing that they do so because they actually have their main repository in Subversion, and a lot of developers then import it into Git because Git can actually merge things for you. So you can take a Subversion tree, merge it into Git, just import it into Git, let Git do the merge, which would be a major headache to do in Subversion, create a merge commit, and actually export it back to Subversion, and nobody else even knew you used Git, right? It's kind of sad, but we have cases of people talking about doing exactly that inside companies. Git has not been around in a form where a lot of people will be comfortable using it for more than half a year or so. We have had so huge improvements to the user interfaces that realistically a year ago at a commercial company, a lot of people would just have said it's too hard to use. I think we're way past that hump. Git is much easier to use than CVS, really. Most people tend to, it's easier to use than anything else. It's just get over it. You don't have to use all the powerful tools. Some of them might be things you want to explain and introduce to people only after they got over the initial hump of understanding what distribution really means. But the basic stuff is really easy to do.
One characteristic of a centralized system is that it's the original developer who has to resolve any merges, who has to fix merges. How do you do that in Git, and how do you minimize merge conflicts?
Thank you for asking me that question. Did I tell you to ask that question first? One of the really nice parts of Git is, Git does make things much easier to merge than a lot of other systems. Merging a branch in CVS tends to be really painful. One of my main statistics is the kernel is actually one of the biggest open source projects. We have 22,000 files. We've used Git for 2 years. During those 2 years, we have averaged 4.5 merges a day, every single day. That's not something you do in something where merging was hard. So Git makes merging easy, but you will inevitably have cases where 2 maintainers send me the question to, please pull my stuff. And I pick one of them at random, usually because their mail happened to be first in my mailbox, and I pull their stuff. And another person had made changes that, it doesn't happen that often, but it does happen, made changes that just clashed so much that I said, I could fix this up, but I really don't want to. I didn't write the code. It's not my area of expertise. It's networking or something like that. I can't really judge it. I can't test it. So asking me to resolve the merge is just crazy. It's not how you should do things. Okay, the Windows machine flaked out again. So what happens is, I actually, remember, distribution means nobody's special. So instead of me merging, I just push out my first tree that didn't have any merge issues, and I tell the second person, hey, I tried to pull from you, but I had merges and they weren't completely merge conflicts and they weren't completely trivial, so I decided you get to do the honors instead. And they do. And they know what they're doing because it's their changes. So they can do the merge, and they probably think I'm a moron because the merge was so easy and it was obvious I should have taken their code. But they do the merge, and then they update their tree and say, hey, can you pull from me now? And I pull from them, and they did all the work for me. That's what it's all about. They did all the work for me. So, and I take the credit. Now I just need to figure out step 3, profit, right? But that's kind of another thing that comes very naturally from being distributed. It's not something that is special to Git. Git makes merging easier than anything else. But Git does it exactly because Git is distributed. Yes.
So I guess I don't entirely understand why I think that it's necessary to have a distributed system to have. I mean, it seems like you get a lot of the good effects, at least for a place or for like corporate development. For open source development, it seems very useful that everybody can work on their own, sort of. But when you really have a sort of centralized corporate tree, then a centralized system with really cheap branches, wouldn't that give you pretty much the same effect? Or is that just impossible to do?
No. I will argue that centralized systems can't work. But it is clearly true that if you're in a tightly controlled corporate environment, centralized systems work better. And it's unquestionably true that people have been able to use centralized systems for the last 35 years. I mean, nobody's really arguing that centralized systems cannot work. They cannot work as well as distributed systems. One of the issues you tend to have is centralized systems inevitably have problems when you have groups in different locations. It tends to work really well if you have a really beefy backbone fiber, and I guess for Google you probably do have some kind of network going. I don't know. And maybe it's not as big of an issue as it is for other projects. But trust me, not having to go over the network for everything is a huge performance saver. Well, I can't show you demonstrations, and it's not a very interesting demonstration anyway, but this is a laptop that is, 4 or 5 years old. It's like a Pentium M 1.6 gigahertz thing. I could show you me doing a full diff of the kernel on that laptop in whatever, just over a second. On my main machine, it takes less than 1/10 of a second. That's the kind of performance you simply cannot get if you have to go over the network. We're talking a couple of packets going over the network, and you just blew the performance. So if you have a decentralized system and you're used to having something like commit or diffing the whole source tree taking 30 seconds, maybe 30 seconds doesn't sound that bad to you. Trust me, when you're used to it taking 1/10 of a second, 30 seconds sounds pretty bad. So there are huge performance issues, even if you have a good network. Never mind the fact that most people don't have a good network. The other thing is, branches really, even if you make them technically very cheap to create, just the fact that you create them and everybody sees them means, because everybody will see them since they're centralized, basically means that you don't want to make branches willy-nilly. You will have namespace issues. What do you call your branch? What do you call it? Test. Oh, by the way, there's 5,000 other branches called test 1 through 5,000, right? So now you have to make up all these naming rules for your branches because you have a centralized system that has a centralized branch namespace, which is kind of inevitable when you have a centralized system. How does that work in distributed environments? You call your branch test. And it's that easy. Or actually, you shouldn't call it tests. You should basically name your branches the way you name your functions. You should call them something short and sweet and to the point. What is that branch doing? Git, by default, gives you one branch that is called master. It's short and sweet and to the point. It's the master branch, right? But you can make a branch that is called experimental feature X, and it will be obvious. But this is something you simply cannot do in a centralized environment. You cannot call branches experimental feature X. You have to make up stupid, idiotic names. I worked for a company that had as nice as you probably can make them, scripts around CVS that helped you make branches. You could actually make branches with a simple command. It didn't take that long. It picked a name for you. Exactly because it would pick the number. So you'd give it a base name and you would say, this is my branch for doing so-and-so, and it would call your branch so-and-so -56. And it would tag where you started that branch because in CVS you need to do that too. And then you needed to, it took a while, but it worked. You can do these things in centralized systems, but you don't need to. If your system is decentralized, it just works. And that is how it should work. So I'm not going to force you to switch over to decentralized. I'm just going to call you ugly and stupid. That's right. That's the deal. Anyway, we are on the performance slide.
Can I ask a question?
Yes. There.
2 questions, actually.
Okay.
So one is, how many files would Git take? And then the second one, let's say if you have a humongous tree under Git,
yep.
Would it be possible to check out part of the tree?
Great questions. Those questions actually kind of dovetail into a different issue, even though they are performance related. One of the things that Git is really special about, and this is special even with regards to things like Mercurial, which is otherwise fairly similar, Git tracks your content. It never, ever tracks a single file. You cannot track a file in Git. What you can do is you can track a project that has a single file, but if your project has a single file, sure, do that, and you can do it. But if you track 10,000 files, Git never, ever sees those as individual files. Git thinks of everything as the full content. All history in Git is based on the content of the history of the whole project. This has implications for performance. When you use CVS, it's perfectly fine. It's stupid, but it's perfectly fine to have one huge repository that has 1 million files in it, because at the end of the day, CVS actually thinks of all those 1 million files as a single file. And you can actually ask CVS to only update that one file because CVS really thinks in those terms. And that's actually true of pretty much everything else too. It is actually even true of BitKeeper. That was one of the mistakes in BitKeeper. The problem with thinking in terms of single files is that quite often, especially if you're a high-level maintainer like me, I have 22,000 files to track. I don't care about one of them. I might care about a sub-collection of them that contains maybe 1,000 files. I might care about the USB subsystem, but I never care about the single file. So Git tracks everything as a collection of files, and if you ask for the history of a single file, Git will literally start from the global history and simplify it. It's a fairly efficient system. It's a very efficient system. You would normally not even realize that it does that. But it does mean that if you try to track 1 million files in one repository, when you then ask for a single file history, it's going to be slower. So it has different scaling properties than a lot of other systems for this very fundamental design reason. We have used big repositories. We've imported things like the whole subversion history of, well, maybe not the whole, something like 3/4 of the subversion history of the whole KDE project. And the KDE people are, I shouldn't call them, I won't call it, I like KDE, but trust me, they put every single component in one repository. Not very smart. So what you ended up with, you had a repository that took, I think, 8 gigabytes under the CVS tree, and Subversion blew it up to like 3 times that size. Maybe it wasn't quite 8 gigabytes in CVS, but it was big. It was more than 4 gigabytes. Git would actually compress it down to something like 1.3 gigabytes. So Git is actually very efficient at taking this project and just smushing it together, and most things actually performed very well, but certain things did not. The things that do not perform very well, if you put 1 million files in one repository, is initial clones. When you get it all. You put it in one repository, Git thinks of it as one thing. Don't do that. If you have multiple components, do them as separate repositories. You can actually have what we call a super project that contains pointers to other projects, and the user interfaces there are somewhat lacking. But you keep separate projects separate. And then you avoid the problem of, okay, you have to get it all. Because with Git, you do have to get it all.
Linus, what if they all share code? All these projects?
If they all shared code. What you can do with Git, if you actually have a lot of shared stuff, since Git actually internally uses a content addressable file system, if there are identical files with identical content, Git will actually use the exact same object for them and save you tons of space. You can have these shared objects and still have them as separate entities. You can still see them as separate repositories that just have a shared file system backing the data. You can do that. If you actually have shared code in the sense that you, for example, have a library that is used by 5 different things, that's when you use the super project support, where you have one Git repository that just tracks all the other Git repositories. It may contain stuff like shared build infrastructure too. But then the individual pieces are individual. This is like CVS modules. In CVS, modules aren't really individual, but that's because of the way in CVS the directory is kind of a thing of its own anyway. So CVS modules are kind of a combination of this and just tracking them all. But you can basically think of it as CVS modules. And we do support it, but I do have to admit that code is fairly recent, and that's one area where our user interfaces right now are definitely lacking. There was probably some other part to that question that I completely forgotten. I can't hear that.
I mean, the question was, can you have just part of the files pulled out of the repository, not the entire repository?
You can export things as tarballs. You can export things as individual files. You cannot. You can rewrite the whole history to say, I want a new version of that repository that only contains that part. You can do that. it's a fairly expensive operation. It's something you would do, for example, if you import an old repository into one huge Git repository, and then you can split it later on to be multiple smaller ones. You can do it. What I'm trying to say, you should generally try to avoid it. It's not that Git can't handle huge projects. It's that Git won't perform as well as it would otherwise, and you will have issues that you wish you didn't have. And so I'm skipping this and going back to the performance issue. One of the things I want to say about performance is a lot of people seem to think that performance is about doing the same thing, just doing it faster. And that's not true. That's not what performance is all about. If you can do something really fast, really well, people start using it differently. One of the things I wanted to make sure is that merges go really, really quickly, because I want people to merge often and merge early, because it turns out it becomes easier to merge. If you merge every day, suddenly you never get to the point where you have huge conflicts that are hard to resolve. So if you actually make branching and merging easy, you actually avoid a whole class of problems that you otherwise have a really, really hard time avoiding. So for example, let's go back to one of the things where I think the designers of Subversions were complete morons. Strong opinions, that's me, right? There's a few of them in the room today, I suspect. You're stupid. Subversion, for example, talks very loudly about how they do CVS right by making branching really cheap. It's probably on their main web page where they probably say that branching in Subversion is an O1 operation. You can do as many cheap branches as you want. Never mind that the O1 is actually pretty large O, I think. But even if it takes a millionth of a second to do branching, who cares? It's the wrong thing you're measuring. Nobody's interested in branching. Branches are completely useless unless you merge them. And CVS cannot merge anything at all. You can merge things once, but because CVS then forgets what you did, you can never, ever merge anything again without getting horrible, horrible conflicts. Merging in Subversion is a complete disaster. The Subversion people kind of acknowledge this, and they have a plan, and their plan sucks too. It is incredible how stupid these people are. They've been looking at the wrong problem all the time. Branching is not the issue, merging is. And merging, they didn't do squat for 5 years after the fact. That is sad. So performance is important, but you need to look at what matters. Performance for making a branch under Git, it's literally you create a new file that is 41 bytes in size. How fast do you think that is? I don't think you can measure it. You could, if you use Windows, you can probably measure it because file, but whatever. It is so fast you can't really measure it. That's creating a branch. Nobody cares. It's not an issue. That's not it. The only thing that matters is how fast can you merge. In Git, you can merge. I merge 22,000 files several times a day, and I get unhappy if a merge takes more than 5 seconds, and all of those 5 seconds are just the downloading of the diffs. Or not the diffs, it's the deltas between the two trees. The merge itself takes less than half a second, and I don't have to think about it. What takes longer than the merge is after every merge, by default, Git will do a diff stat of everything that changed as a result of that merge, because I do care about that. When I merge from somebody, I trust them, but on the other hand, hey, they might have stopped using their medication. So, I mean, I trust them, but let's just be honest here, they might have been okay yesterday. Today, not a good day. So I do a diff stat, and Git does that by default. You can turn it off if you really want to, but you probably shouldn't. It's fast enough anyway. The diff stat usually takes, if it's a big merge, the diff stat usually takes a second or two. Because creating a diff and actually doing all the stats on how many lines changed, that actually is much more expensive than doing the merge itself. That is the kind of performance that actually changes how you work. It's no longer doing the same thing faster. It's allowing you to work in a completely different manner. And that is why performance matters and why you really shouldn't look at anything but Git. Mercurial is pretty good, but Git is better. I think I'm running out of time. We'll see if we have any. Oh, okay, this one is still interesting. We never got to the implementation part. You really don't care. I will say so much about implementation is the implementation is really simple. The code data structures are really, really, really simple. If you then look at the source code and realize it's actually it's not 100,000 lines, it's maybe 80,000 lines, and most of it is C, and the kind of C I write, most people don't understand. But I commented. The source code may sometimes look complicated because we are very performance-centric. I am. I really care. And sometimes to make things go really fast, you have to use more complicated algorithms than just checking one file at a time. When you're doing 22,000 file merges, you don't want to check one file at a time. You want to check the whole tree in one go and say, oh, they're the same. I didn't need to do anything, right? So Git does things like that, and that kind of blows the source code up a bit because doing it well is complicated. But the basics are really, really simple. And one of the basics is this trust and reliability thing. Every single piece of data, when Git tracks your content, we compress it, we delta it against everything else, but we also do a SHA-1 hash of the content, and we actually check it when we use it. If you have disk corruption, if you have RAM corruption, if you have any kind of problems at all, Git will notice them. It's not a question of if, it's a guarantee. You can have people who try to be malicious. They won't succeed. You need to know exactly 20 bytes. You need to know the 160-bit SHA-1 name of your top of tree. And if you know that, you can trust your tree all the way down. The whole history. You can have 10 years of history, you can have 100,000 files, you can have millions of revisions, and you can trust every single piece of it. Because Git is so reliable, and all the basic data structures are really, really simple. And we check checksums. And we don't just check some piddly UDP packet checksum that is a 16-bit sum of all the bytes. We check a checksum that is considered cryptographically secure. Nobody has been able to break SHA-1, but the point is, the SHA-1, as far as Git is concerned, isn't even a security feature. It's purely a consistency check. The security parts are elsewhere. So a lot of people kind of assume that since Git uses SHA-1 and SHA-1 is kind of used for cryptographically secure stuff, they think that, okay, it's a huge security feature. It has nothing at all to do with security. It's just the best hash you can get. Having a good hash is good for being able to trust your data. It happens to have some other good features too. It means that when we hash objects, we know that the hashes are actually well distributed, and we don't have to worry about certain distribution issues. So internally, it means from an implementation standpoint, we can trust that the hashes are so good that we can use hashing algorithms and know there are no bad cases. So there are some reasons to like the cryptographic side too, but it's really about the ability to trust your data. I guarantee you, if you put your data in Git, you can trust the fact that 5 years later, after it was converted from your hard disk to DVD to whatever new technology and you copied it along, 5 years later, you can verify that the data you get back out is the exact same data you put in. And that's something you really should look for in a source control management system. One of the reasons I care is we actually had, for the kernel, we had a break-in on one of the BitKeeper sites where people tried to corrupt the kernel source code repositories. And BitKeeper actually caught it. BitKeeper did not have a really fancy hash at all. I think it's a 16-bit CRC, something like that. But it was good enough that you could actually see clumsy attempts. It was not cryptographically secure, but it was hard enough in practice to overcome, that it was caught immediately. But when that happens once to you, you're kind of, you got burnt once, you don't ever want to get burnt again. Maybe your projects aren't that important. My projects, they're important. There's a reason I care. This is also one of the reasons, to go back to the distribution angle a bit. When you do Google, for example, Google Code, you have your source repositories that you help people maintain, and I think you do so under Subversion. And I would never, ever trust Google to maintain my source code for me. I'm sorry. You're just not that trustworthy. The reason I really prefer a distributed system is I can keep my source code behind 3 firewalls on a system that does not allow SSH in at all. When I'm here, I cannot read my email because my email goes onto my machine, and the only way I can get into that machine is when I'm physically on that network. So maybe I'm cuckoo, maybe I'm a bit crazy, and I care about security more than most people do. But the whole notion that I would give the master copy of source code that I trust and I care about so much, and I would give it to a third party, is ludicrous. Not even Google. Not a way in hell would I do that. I allow Google to have a copy of it, but I want to have something that I know nobody touched. And by the way, I'm not a great MIS person, so the disk corruption issue is definitely a case that I might worry about because I don't do backups. So it's okay if I can then download it again from multiple trusted parties. I can verify them against each other. That part is really easy. I can verify them against, hopefully, the 20 bytes that I really, really cared about. Hopefully, I have that in a few places, right? 20 bytes is easier to track than 180 megabytes. And corruption is less likely to hit those 20 bytes. If I have those 20 bytes, I can download a Git repository from a completely untrusted source, and I can guarantee that they didn't do anything bad to it. That's a huge thing, and that's something when you do hosted repositories for other people, if you use Subversion, you're just not doing it right. You're not allowing them to sleep well at night. Of course, if you do it for 75,000 projects? Most of them are probably pretty small and not very important, so it's okay. Right. That should make people feel better. I have a few more slides. I think we're over time. I'm not even going to bother showing them. They're not that interesting, I think. I talked a bit about this, about content versus individual files. Git tracks content. It means that Git is there's the only example command line in the whole presentation. Git K is the graphical viewer of history of a Git project. It's a tickle TC script, TK script that is really only doing viewing of stuff that Git is really good at showing you. And this is the kind of command line I use as a top-level maintainer. I want to be able to say what changed since a particular version, maybe since a particular date, I can do that easily, in those 2 directories, or in those 2 directories and that file. And what this will show me is the global history as it pertains to those parts of the repository. It is more expensive to compute than the global history. But if my laptop was actually connected to the AV system, I could show you it. Even on that laptop, it comes up in seconds. It's not that expensive. I mean, it is that expensive, but we're that good. So, and this is something that is really, really unique to Git. Nobody else can do it. And it's a hugely important feature. Maybe it's not so important to individual developers because individual developers often do think in terms of single files. But it is important for the people who merge stuff, it is important for people like me and the people I work with directly, because they never basically care about a single file. And they do care about these kinds of features. Somebody sends a bug report, which bug reports are usually not very good, but maybe the bug report is good enough that you can pinpoint, okay, SCSI subsystem. That's the command line. You can't say which file, but you can do this and say, okay, that will cut it down to, from the 15,000 commits we've had since last week, it will cut it down to 50. That's a huge deal. That is something that nobody else can do, I guarantee you. So that's the reason you want to use Git. That's what it all boils down to. It's safe. It is so fast that it can do things that nobody else can do. It does things that nobody else can do even slowly, and it's distributed. So go and spread the word. Oh, we have one more question, I guess. What is the timing like? I don't know.
Quickly.
Yep.
So one of the reasons why we would switch from Perforce is really scalability and performance. Otherwise, people would just say, just keep using it.
Right.
Would we be exchanging one set of scalability performance problems for another set of scalability performance problems?
Yes. So I already mentioned the fact that I don't know how you maintain stuff in Perforce, but when and if you do a switch over to Git, what you want to make sure is, because of this content model, you need to do it at sane content boundaries. And the content boundaries usually are actually pretty self-obvious. I mean, they really are. You have the compiler, you have the main source, you have the documentation. Well, you probably have the documentation spread out, but you may have some like user visible documentation. Well, maybe Google doesn't, but a lot of companies have a separate set of documentation that they give to customers. And then they have the documentation that goes into each individual package is package-based. So one of the things you do have to think about with Git is you want to make sure it is in a somewhat sane hierarchy. Git can handle, Git can easily handle largest projects. You can have 10,000 lines and files, and that's not a problem. The kernel is 22. We've done tests with 100. It's fine. It's faster than anything else. With a million files, I suspect other systems will be faster at some things, right? And that's the kind of situation I don't want you to get into. But if you do that basic setup correctly, Git will be basically faster at anything, pretty much everything, than anything anybody else will. I am very confident about Git performance. One of the things we don't necessarily do really well is the CVS annotate. People use CVS annotate a lot if they use CVS. I'm told it sucks under Perforce too, so you probably don't use the Perforce version of annotate. I'm not sure. But CVS users are used to CVS annotate. It's the one operation that CVS can do faster than Git, because CVS does track things one file at a time. Git doesn't. Git has an annotate, but it will actually find, you can ask it, please, if you've moved a function from one file to another, Git will literally tell you the history of that function even across that move. Not a file move, a function within a file. It will go and dig back and say, hey, those 2 lines actually came from that other file 5 years ago. That is, again, something nobody else can do, and it boils down to the same thing. It's the content that matter, it's not actually the files. But it does make it a much more expensive operation, so if you go back 5 years, maybe it takes 30 seconds. On the kernel, it takes a second for any file I have. We started from no history 2 years ago because we just made the decision that let's not make it more complicated than it needs to be. So right now, we only have 2 years of history in the kernel. We have more history in other projects that we've done timings on. So we've done timings on importing the KDE and things like that with more history. But there are performance issues. But most of them are, Git is 1 or 2 orders of magnitude faster. So most of them are the good kind. And if you find something, we actually have a really, really good community. The Git mailing list is fairly high signal to noise, it does get a fair amount of emails, but it's actually a very pleasant mailing list. So if anybody's interested, read the sources first, but start looking at the mailing list archives. We have our flames, we have our pointless discussions, but most of it is actually very good. Okay, thanks.